when ice cubes are kept at a normal temperature, we all quickly say that it changes its state from solid to liquid. It starts melting. Do you know the temperature at which it starts to melt or it melts completely? The theory behind this phenomenon is nothing but differentiation. Differentiation helps to calculate the change in temperature with respect to time. Now, what is differentiability or derivative of a function or differentiation of a function? Differentiation is nothing but calculating the rate at which a quantity changes. The process of finding the derivative of a function is called differentiation. Derivative of a function f with respect to x is denoted as f dash of x, or it can also be written as d by dx of f of x or dy by dx. Another way we can write it as y dash. Now let us find the derivative of a function at point C. Let f be a real function and C be a point in its domain. Then derivative of a function at point C is given as f dash of C is equal to limit x tends to C f of x minus f of C the whole divided by x minus C, provided that the limit exists. We know that limit exists when the left-hand derivative should be equal to the right-hand derivative. Now, let us find the left-hand derivative and right-hand derivatives. The left-hand limit of a function at a point x is equal to c minus h and h tends to 0 are given as limit x tends to z minus f of x minus f of c by x minus c. Again, limit x tends to 0, f of c minus h minus f of c by c minus h minus c. We just substitute x by c minus h. Again, we can write it as limit h tends to 0, f of c minus h minus f of c by minus h. This is a left-hand limit. Now coming to the right-hand limit of a function at a point x is equal to c plus h and the h tends to 0 and it is given as limit x tends to c plus f of x minus f of c by x minus c, which is equal to limit h tends to 0, f of c plus h minus f of c by c plus h minus c. Substituting here x by c plus h, which is again equal to limit h tends to 0, f of c plus h minus f of c by h. Next we will see an important theorem, and the theorem statement is: if a function is differentiable at a point C, then it is also continuous at that point. Let's see the proof. Let f is differentiable at C. We have f dash of C is equal to limit x tends to C f of x minus f of c by x minus c. We have to prove the function is continuous. So, consider x is not equal to c. So, for x not equal to c, we have to find f of x minus f of c, which can again be written as f of x minus f of c by x minus c into x minus c. Alright. Now, applying the limit on both sides, we get, so limit x tends to c f of x minus f of c is equal to, applying the limit on the RHS, we get limit x tends to c f of x minus f of c by x minus c into x minus c. Now we have to apply the algebra of derivative rule. That is, limit f plus or minus g can be written as limit of f plus or minus limit g function. Also, limit of f into g can be written as limit of the first function, that is f, into limit of g. So we have to use this derivative rule. Okay. So what we get? Limit x tends to c f of x minus limit x tends to c f of c is equal to, the RHS becomes limit x tends to c f of x minus f of c by x minus c into limit x tends to c x minus c. So here in the LHS, c is a constant and the first term of RHS, this is nothing but your f dash of c, and the second term here is, this will tends to 0. So f dash of c into 0, we get it as 0. So limit x tends to c f of x is equal to, bringing this to the other side, we get it as f of, hence we can say the f is continuous at the point x is equal to c. But the converse of this need not be a differentiable function. The theorem statement is, every differentiable function is continuous. Now we are going to prove the converse of the above theorem is not true. Let us consider f of x is equal to mod x. We know that mod x is a continuous function always. So we are going to prove that it is not differentiable. Now we know f of x can be defined as f of x is equal to minus x for x less than 0, and f of x will be equal to x for all x greater than or equal to 0. We are going to prove that the left hand limit is not equal to the right hand limit. So the left hand limit at point c is equal to 0 is given by limit h tends to 0 f of c minus h minus f of c the whole divided by minus h. This can again be written as, substituting the value of c as 0, we get limit h tends to 0 f of 0 minus h minus f of 0 the whole divided by minus h. Here the function f of 0 minus h means the h is less than 0. So this equation can again be written as limit h tends to 0 minus of 0 minus h minus 0 by minus h, and we get it as limit h tends to 0 h by minus h, which is equal to limit h tends to 0 of minus 1, which is nothing but minus 1. Now coming to the right hand limit, it can be written as limit h tends to 0 f of c plus h minus f of c by h. So substituting the c as 0, we get it as limit h tends to 0 f of 0 plus h minus f of 0 by h. So we get it as limit h tends to 0, h minus 0 by h, which is nothing but limit h tends to 0, h by h we get it as 1 and the answer will be 1. So we got the LHS as minus 1 and the right hand limit as 1. So the LHS limit is not equal to right hand limit. So the f is not differentiable at point 0. So we have learned the conditions for a function to be differentiable at a point. Now let's discuss certain rules that were established as a part of the algebra of derivatives. Here is the first one. U plus or minus v the whole dash is equal to u dash plus or minus v dash. Next rule is nothing but product rule or Leibniz rule, which gives the derivative of the product of two functions. That is, u into v the whole dash is equal to u dash into v plus u into v dash. Read as derivative of the first function into second plus first function into derivative of the second function. The last rule is the quotient rule. That is, u by v the whole dash is equal to u dash into v minus u into v dash by v square, where v not equal to 0. We shall now see the derivatives of some standard functions. First one, x raised to n, its derivative is n into x raised to n minus 1. Now, for the function sin x, its corresponding derivative is cos x. For cos x, the derivative is minus sin x. And what about tan x? The derivative of tan x is nothing but sec square x. Now, suppose your stock is increasing for a certain period and starts decreasing at a particular point. Check how differentiability helps to find its rate of change. So, which we will discuss in the next video. Now, we will summarize the points that we are discussed in this particular section.
Manorama Horizon. Learning made simple.